ช่วงครึ่งหลังของเช้าวันนี้ก็จะได้เริ่มปฏิบัติกันแล้วนะครับแต่ละท่านคงจะได้รับคิดเลขกันแล้วนะครับเดี๋ยวจะได้ลองฝึกปฏิบัติการใช้ดูนะครับก็ถ้ามากันพร้อมแล้วนะครับเดี๋ยวผมจะขอแนะนำนะครับตัวแทนจาก CASIO Marketing Thailand นะครับและก็ Central Marketing Group นะครับที่จะมาช่วยในช่วงของเวิร์กช็อปนี้ด้วยนะครับถ้ามีคำถามก็สามารถถาม2ท่านนี้ได้นะครับคุณนนทวัฒน์นะครับอิ่มสมบูรณ์นะครับจาก CASIO Marketing Thailand นะครับท่านนี้นะครับแล้วก็คุณชัยฤทธิ์กองกล่ำนะครับ Central Marketing Group นะครับแล้วก็เรามีคุณอรวลีเหลืออุตสาหกุลนะครับจาก Central Marketing Group นะครับมาลองเสริมด้วยนะครับท่านคำถามก็สอบถามได้เลยนะครับ so please proceed to the next session
Is this on? It is, okay. Thank you very much to the colleagues from CASIO Thailand who will give you some help if you need help. As you can see, this first session, this is a hands-on session, so you will be doing using your calculator and I will give you some advice with mine, but I'm hoping that in this session you will become familiar with how the calculator works and how to adjust it so that it works better, and familiar with some of the functionality. You won't need, at the moment, anything other than a calculator. Maybe you might like a bit of paper to write things down. There are some things in your envelope, but we will not use them just yet. I will tell you when to use those. Okay, so getting started. Where's the on button? Well, the on button is here. It says on. And I know everyone has already pressed their on button, but you might have done other things. So I'm going to suggest, I very rarely do this, but I'm going to suggest we start by resetting your calculator. So on my calculator, I'm able to I have a thing here called a key log, which I don't normally use, but I'm going to tap the shift key and then number 9. So please do the same on your calculator, shift key and then number 9. And I'm going to ask you to initialize everything, number 3. And okay? So we say, yes, it's okay. And the AC key, this one here, clears everything. So now everyone's calculator is the same. Firstly, notice in the top of the screen, there's some little symbols here. One of those tells you that the calculator is in what's called math mode. That means it shows mathematics in the proper way. The other one says we are using degrees, D for degrees. So that is just a reminder. Now, let's put in something very unsophisticated. 1, 2, 3, multiplied by 4, 5, 6. And notice, oops, 7. I made a mistake. So I can just delete and change to a 6. Or if I meant to be 3, 4, 5, 6, I can backspace and make it 3, 4, 5, 6. So we can easily change things before we press equals. That's very important for students. You can see what's on the screen and you can change it. When we are happy, press equals. Now, this is a large number. But students who are just learning mathematics often have trouble with large numbers, so do people like me. it's possible on this calculator to show the number better. So here's how. Tap Shift and Setup, which is the key over here, next to the On key. You can see there is a menu. And over here you can see we're at the top of the menu. Go down and down. And now we can see digit separator. Digit separator. Separate the digits. Use number 4. Tap 4. On or off? Let's say on. It's now finished. If I want to do the same thing again on the calculator, the same calculation as last time, just press equals. Notice the difference. Now there is a space here. 425,088. Scientists and engineers don't care about that. Children do. It's easier to read. Okay. Now, let's do something very simple to start with. And I'm thinking in this session of younger children in early secondary years or later primary years. And many children, if you say, what is, and you put this in your calculator, but do not press equals. 2 add 3 times 4. Don't press equals. Now tell the person next to you, or behind you in your case, sir, what should the answer be? What do you expect? 2 add 3 times 4. What do you expect? You expect 14. Some calculators on watches, some calculators on phones, some calculator apps, many calculators in offices, most calculators in markets give the wrong answer because they're not designed for education. The answer is, of course, 14. We know that you need to do multiplication before addition. Now, I'm going to ask you, and I won't normally do this, but please follow me carefully. I'm going to change this by editing it and use this left button to go up. Just tap it once. Notice the cursor is now up here. Change the 4, make it 5. What do you expect the answer to be? 17, I hope. Do it again. Edit, delete the 5, make it 6. We now expect 20. Do it again. Change the 6, make it 7. And do it again. Change the 7, make it 8. That's enough. Now, look at your calculator screen carefully. Up here, there's an arrow. You probably didn't notice it because you were busy doing something else. The arrow says there's something up there. How to see what's up there? Press this button here. We can see what we did. And students can see 14, 17, 20, 23, 26. What's next? 14, 17, 20, 23, 26. Should be 29. Should be. We can test that. Get it? Change the 8. Make it 9. Yes, it is. We are affirming our guess. There's a pattern. In mathematics, there is always a pattern. And we want students to look for those patterns and to say, why is that pattern there? Why is it going up by 3? Can you make a pattern that goes up by 4? You make one. Do it now. Do the same, but make the pattern go up by 4, not by 3. Start with a different number and make some changes. Do it now, so that your pattern goes up differently. There is, of course, lots of ways. 3 add 4 times 2. 3 add 4 times 3. 3 add 4 times 4. 3 add 4 times 5. Goes up by 2. 11. Goes up by 4. 15, 19, 23. And the next one would be 4 more, 27. So that's not a very important thing in itself, but I'm just getting you used to using the calculator, going up, changing things, seeing what's there, and so on. But it's also worth noting that an educational calculator will do the mathematics correctly, the arithmetic correctly. Okay. You noticed before the fraction keys, I'm sure. I use them sometimes. Fraction key over here. You can just type the fraction key and put in the fraction. 3, and then use the arrow key, move down to 4. And equals. Wonderful key for students learning about fractions and decimals is S to D. S stands for standard, the standard way of representing a number. And if the number is a fraction, the standard way, of course, is a fraction. I don't like decimals. I really don't like decimals. When I have 3/4, I know what it means. When I have 0.75, I'm never sure. Has it been rounded? Is it an approximation? I don't know. So I don't personally like decimals. I would prefer to use fractions. And when I can, I do. And you know, I would like students to do that too. I would like students to develop the same comfort with fractions that we have. But to also know that 3/4 and 0.75 are the same number. Many students think that a fraction is 2 numbers, the top one number and the bottom number. And they do things with the top number and the bottom number that make no sense to them at all. They find common denominators and they multiply things together and they turn things upside down and they do strange things. I like them to think a fraction is 1 number. So there's a number. You can do computation with fractions if you want to. So 2, and I've put the number first, and now the fraction key. 2/5. If you wanted to add 2/5 and 3/7, 2/5 added to 3/7, firstly, you will almost certainly be in a school, because nobody out there ever does that. Nobody. The only people who would ever add 2/5 and 3/7 are in the maths class in a school. But if for some reason you wanted to do that, then you have to be careful how you do it. If we just said 2/5 add 3/7, that's probably not what we meant. And I'll delete. If we want 2/5 add 3/7, firstly you must move this one that way. Move it out of the fraction, like this. And now add 3/7 and equals. Okay? So you have to be careful how you enter numbers. As I said previously, one of the things we want students to learn about fractions is what they mean. So if you ask students, and I have tried this, and it's always a bit concerning, if you ask students to divide, say, 3 pizzas amongst 8 people, how much pizza do they get each? It's an unusual student that says 3 things divided 8 times gives that result. They don't do that. They don't actually think about fractions like that. But that's the meaning of 3/8. 3 divided by 8. And of course the calculator shows 3 divided by 8. If you like decimals, Lord knows why, you can write it as a decimal, or tap the decimal button again to write it as a fraction. All the time you can flip from fractions to decimals. Every time you do that as a student, every time, you are again being confronted with the fact that every number can be represented as a fraction or as a decimal or as an irrational number. But we can flip between one and the other. It's a choice. In many school curricula around the world, we teach people how to convert from fractions to decimals, as if somehow it's a big idea. I think it is a big idea, but I don't think it's worth spending a lot of time converting. Okay. If you get a strange fraction like 15 divided by 7, or some other top-heavy fraction, you can see the calculator produces the fraction, and you might, if you turn it to a decimal, you can see that it's a little bit more than 2. But if you leave it like that, the buttons down here, this command here, Shift and S to D, I'll put this back again momentarily, Shift and S to D will, and equals, will turn it back the other way. Shift and S to D. Shift and S to D. So students can see how to flip from one to the other. Okay? And if you would like to enter a fraction as a mixed fraction, it's over here, just above the fraction key. So Shift and fraction. So we can represent a number as 3, use the arrow key, and 1 down quarter, 3 1/4. And the result is 13/4. If students are thinking, what number is 13 over 4? They can hopefully do it in their head, or see that it's 3.25, or see that it's 3 1/4. You have a choice. Okay? If you would like to always see numbers like this, always, you can tell the calculator to always do that. Here's how. Shift and set up. Shift and set up. That's shift and the menu key. Down, down, down. I missed it. Up, up, sorry. Fraction result. Here we are. Fraction result. Find fraction result. Number 1. So you can have it like that all the time, or like this all the time. So if you had it like that, number 1, then when you did something like 15 divided by 4, the result is 3 3/4. And you'd have to use this to go back the other way. I don't like that, personally, but it's up to you. I'm going to change mine back again because it will irritate me. Fraction number 2. Okay. Now, you might have noticed that you can make a continued fraction if you want. 1. Oops. 1 add 1 over. 1 add 1 over. 1 add 1 over. 1 add 1. You can do things like that, as we could write on a blackboard or in a book. And when you press equals, you can get the result. So it's possible to make more complicated commands. Okay, but we're not, and students who are interested in continued fractions can have lots of fun with that. But here we are just finding the on button, so we won't be distracted into doing that. Okay. Notice still, this arrow is still here. You can still go back and see what you've done. It's all there. It's very convenient to see what you have done if you are a student. Okay. Right, the power keys. There's a power key here, there's a power key here, and there's a power key there. So if you wanted to find the third power of 7, when I was in Indonesia 2 days ago, everybody started by tapping this button, and then putting the numbers in. But what I suggest you do to find 7 to the power 3, tap 7, and then this one, and the 3. 7 to the power 3 is 343, as you know. Or if you like, edit that, back again, change the 3, make it 5, 7 to the power 5. Or if you want a big number, change the 5, make it 15. And if the number is very large, you can see it automatically produces scientific notation. Okay. And if you, same way with a fraction, if you want to do something complex like 2 to the power 5 add 8, 2 to the power 5, if you now want to add 8, if you just add 8, it's still up there. That's not what I meant. Delete, delete. Go to the right. And now add 8. So we get 40. 2 to the 5 is 32. Add 8 is 40. So you have to get used to using the cursor. Okay? If we wanted it to be 3 to the power 5, add 8. Up here, back, back. Delete the 3 with 2, make it a 3. And there we have 3 to the power 8. So you need to become familiar with the keyboard like this. Okay. Something that might not be immediately clear, and this is for very young children, is the way the calculator works. It will automatically, well, let me put in a simple number like 1. 1 is a very, very simple number. 1 equals. If you want the calculator to count, if we simply now say add 1, add 1, notice what's happened. It doesn't add 1, it says answer add 1. So because I only said add 1, addition requires 2 things. So add 1 to what? The calculator thinks add 1 to what is already there. So it says answer add 1. And if we tap equals, 1 and 1 is 2. That's unsophisticated. Now if you just press equals, don't do anything but press equals, it will do answer add 1 again. So it will add 1 more. We get 3. Now if you do it lots of times, it's counting by ones. If you have very young children, and if you've got children, say, who are 3 or 4 years old, I have done this work in the kindergarten. Ask children to count out loud as far as they can. And I've often heard little children, say 4 years old, they will count up to 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 2010, 2011, 2012, because they haven't quite understood that it's not 27, 28, 29, 2010, it's something different from that. It's 30. And similarly, if you start with, say, 995 and add 1 and count, if you ask some students what comes after 1,000, I've heard young children say 998, 999, 1,000, 2,000, 3,000, 4,000, but of course the calculator knows it's 1001, 1002, and so on. That's pretty trivial, but it's actually quite powerful for some children. But what if you count backwards? So start at 10 equals, and to count backwards we have to subtract. I'm going to subtract 1. And then every time I press equals, it will subtract 1 again. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, stop. In some countries, we don't let children know about negative numbers. We keep them a secret until they are 12 or 13 years old. I don't know why. Half the numbers are negative. Half. It's a very big secret. So if we keep going, -1, -2, -3, -4, there's nothing funny about that. There's nothing unusual about that. A colleague of mine some years ago wrote a paper in a journal, and she said, why are we keeping it from the children? Why are we hiding these numbers from children? Why do we think we can't deal with positives and negatives? They're there all the time. And of course the calculator has them there. But notice carefully, it might not be immediately clear. This negative is very short, and subtraction is longer. Subtraction is subtract one number from another. Negative is just an opposite. This is an operation. Addition, subtraction, multiplication, division are operations. This is not. So the calculator has two different symbols. This one for the operation, subtract. This one for negative. They are different. And on the calculator, if you want to put in the number negative 3, you should use this one, negative 3. And negative 3 is an interesting number. If you add 3 to it, you get 0. That's what's interesting about it. And of course you can do arithmetic with negative numbers. 5 added to negative 2. 5 added to negative 2, of course, is 3. It's like having $5 and losing $2, or you owe somebody $2. And of course you can do other negative things. Negative 5 added to negative 3. Negative 5 on the number line is over there. And if we add negative 3, we go 3 further back. It's negative 8. And of course, if you want to multiply negative numbers together, negative 2 multiplied by negative 7 is of course 14. So positive numbers and negative numbers are there, naturally. Now, everything goes together. We can make a power. So 25 to the power negative 2. You don't have to only have positive powers. 25 to the power negative 2 looks like, and students might think, looks like 1 divided by 25 power 2. Yes, it's the same. 25 to the power 1/2. It's 5. So we can use positive numbers and negative numbers wherever we use numbers, just as we do in mathematics normally. And we can find some powerful things in that environment. Okay. You can imagine students who are learning about powers and indices and positives and negatives. This is quite powerful. Even 3/7 to the power negative 1. There's a special button for power negative 1. Is 7/3. It's the inverse. What do you multiply 3/7 by to get 1? Well, 7/3. Students can check. 3/7 multiplied by 7/3 is 1, as you would expect. And if you do that repeatedly, 7/3 inverse and inverse again, oh no, 7, I did that later, 7/3. If we now find the inverse, and then do it again and again and again, we can see the fractions, to invert a fraction, you simply switch the numerator and the denominator. So these things we are wanting students to learn are built into the operating system. Okay. Okay. 5 subtract -2. You subtract a negative number, you have to add its opposite. So it's 5 add the opposite of 2, which of course is 7. Students sometimes think 2 negatives make a positive. They remember rules like that. I don't know if you do that in Thailand. Many teachers in Western countries teach students to say things like 2 negatives make a positive. But sometimes they don't. If you have -7 and you add -5, there are 2 negatives and they don't make a positive. So I would rather than remembering rules, students understand the ideas and how the numbers are connected. Okay. Some other things that are built in here. Absolute value. You can see above the left bracket, shift and absolute value is the standard sign for getting the positive part of the number. The absolute value of 3 subtract 5 is how far away are 3 and 5 from each other. And of course the result is always positive. Memories. There's lots of memories on a calculator. So let me show you how to use the memories, because people often don't use them. And I think that's a shame. Young students are learning about variables. So let's use memory A and memory B. On a calculator, there are several memories. There are here A, B, C, D, E, F, X, Y, M. Lots of memories. You can think of a memory like a box. It stores a value. And we can call this the A box. This is the B box. And when we're first teaching students about algebra, we want them to think about the variable as meaning something, the some number. So let's put a number, say 5, into the A box. Tap store. And notice, you probably didn't, but notice as soon as you tap store, see up here, there's a little symbol. It wasn't there before. It tells you what you've tapped. And to store in memory number A, just press the key near the A. It's the negative key. Like so. And let's put a number like 7 into B. 7, store, B. Store. What store means, I'll do that again. 7, store, B. Store is you put something in the box and it replaces what used to be there. So now, what is A? If you tap alpha, this one at the top here, alpha and A, we can find out what the value of A is. Equals. A was 5. And alpha and B is 7. It could be something else, but for the moment it's 7. For students just starting to learn about algebra, though, this is very powerful. 2 alpha A is 2 times A. Some students, I've seen many students in the early part of secondary school who say, if A is 5, 2A is 25. 2, 5. Or some students say, if A is 5, 2, 5 is 7, because they add them. But the calculator knows that 2A means 2 times A. We can, of course, write 2 times A if we want. That's okay too. But the standard way of writing things works. More importantly, alpha A, alpha B, AB. It's not 57, because A is 5 and B is 7. It's 35. It's A multiplied by B. So students just starting to learn about variables, this starts to make sense of them. 2 alpha A add alpha B is 2 times A and B. That's 17. And if we change what is in A, 3 straw A, and now if we do 2 times A, 2 times A, add B, we don't get 17, we get 13, because it's 2 times 3, add 5, or add 7. And when students are just starting out with algebra, having a device that thinks the same way as algebra, I think is actually very, very helpful. And of course, more complicated things like A squared B is fine. 3 by 3 by 7 will be 63. So don't think that because we're just dealing with numbers, we can't start to deal with variables and with symbols. Okay. I've already mentioned with fractions and decimals, 0.7 is 7/10 is 0.7. 0.7 thousand, 70,000 is also the same. 0.7 is also the same. Helping students to see these are just different representations for the same number is very useful. Okay. So, again, just exploring the keyboard. Trigonometry. We've got degrees at the moment. The sine of 45 degrees. We simply write it the same way we normally write it on the page. Sine. And notice the result is the irrational number. It is the exact result. Not for all angles, just for some. If you want a decimal, it's to do a decimal approximation. But that's nicer. Some numbers, like sine of 15, are also irrational, because there are a very small number of the angles that we know exactly. Most of them we know only approximately. And in general, the calculator only deals with approximations. If you do inverse sine, what angle has a sine of, I just press the fraction, notice the it has expanded. Square root of 3 divided by 2. Inverse sign is 60, because these are degrees. Usually, most angles are approximate, however. So the inverse sign of 0.4, the angle whose sine is 0.4, is a decimal number of degrees, not exact. Most real computations are like that. If you don't like decimals for degrees, and you'd like to know what's the angle, tap this button here, degrees in minutes and seconds. And we've got 23 degrees, 34 minutes, 41.44 seconds. So it's it's much more precise, I guess. And if you have, in general, if you put in a number like say 20.4 into the calculator, just any number with a decimal. If you wanted it to be an angle, if you tap here, you can see 20.4 degrees, telling the calculator we're talking degrees now, is 20 degrees, 24 minutes and 0 seconds. And if you don't like that, tap it again. And if you don't like that, turn it to a fraction. You can always flip around. But what about radians? You use radians for older children, not for young children, but just so that you know, you can change the degrees to radians. There's a couple of ways. Just momentarily. Yeah. So suppose we wanted to find the sine of pi. Pi is down the bottom here. Shift and this one, pi over 4. And we wanted to say it was radians. If you tap option, you can see we can choose the angle unit. Angle unit number is 2. Choose radians, number 2. So the sine of pi over 4 radians is root 2 over 2. As you know, pi over 4 is 45 degrees, same as 45 degrees. If you have pi over 4 and you want to represent it in degrees, it's in radians, option, angle unit, radians, and that's 45 degrees. So it's possible to use radians instead of degrees. Okay? If you use radians all the time, and older students probably do, in year 11 and year 12, it's more common to use radians. You can change the calculator by doing shift and setup. Shift and setup. Now if we change to angle unit, we have a choice of degrees and radians and gradients. Choose number 2. And notice on the screen, up here, now it says R. It's not D anymore. Now it is always radians, instead of being always degrees. So what that means is the calculator thinks you are all the time using radians. So if we do something like this, shift inverse sine of square root 3 over 2, it assumes radians. And so the result is given in radians, not in degrees. Okay? So you have a choice. The student has a choice. If it's the student's calculator, they can choose how to use it, how to set it, what they want to do most of the time. If they sometimes, even in radian mode, want to find the cosine of, say, 30 degrees, they have to change the unit to degrees, and then it's okay. I'm going to change my calculator now back to degrees, because for the moment we're thinking of younger children. So, shift and set up angle unit and degree. So now it's a D again. Okay. I didn't say much about irrational numbers. Let me go back a little bit. You find the square root of a number like 12, the calculator will give the exact result, 2 root 3, as you would hope. If you have a number that doesn't break down, square root of 37, it simply says 37. Similarly, if we have decimals that are recurring, like say 2 divided by 3 is a recurring decimal, 0.6666667, so 7 at the end. Of course, it's been rounded to fit the screen. If we want the calculator to say what is the fraction for 66667, it just says 6666667. It doesn't know that we mean to keep going. But if we do want to keep going, 6666666666666, notice there's an arrow now at the end. So the calculator assumes if you go past the end, you mean it to be 2/3, which is very nice. If you have a number like 0.2323232323, and students get sick of typing things in and say, that's enough, what is the fraction? Nothing happens. But if you go a bit further, 232323, past the end, then the fraction is 23/99. And of course the decimal is an approximation. So students can learn about, think about, talk about what is happening with recurring decimals as well as with terminating decimals. Okay, I think that's all I wanted to do on the front here. Oh, you can see other things like the is a cube root function. Cube that somewhere. Oh, factor might be interesting. Oh, we'll do that afterwards. What I want you to do now is, so now we've seen a little bit about how the calculator works. What I'd like to do now is to share with you one of these examples. So inside your envelope, one of them is called number 2, investigating fractions and decimals. So find that sheet, number 2. Now this is going to be very hard. What's going to be very hard? What's very hard is I want you now to pretend you are 11 years old or 12 years old. Pretend you are a student, not a teacher. That is very, very difficult. But you'll never be a teacher if you can't do that, so I'm sure you know how to do that. You have to look at the world through the eyes of someone who does not yet know the mathematics. So I know that's hard, but pretend that's you. Pretend you are someone in your class, you're in maybe year 6 or perhaps year 7, and you don't yet understand fractions and decimals, but we're learning about them. So what I'd like you to do with this is an example of an investigation. It's also an example of a black line master, because you could copy this and give it to 2 students. I suggest not one each, but one between 2, so they have to talk to each other. But we've given you one so you can take it home. So pretend you are a student, and we're going to now do that. I'm sorry that I haven't written this in Thai, but I only know about 3 or 4 words in Thai, and I usually get them wrong. So these are in English, but there are 3 activities here. And these are examples of what I think students might do who don't yet understand fractions and decimals properly, but they might use the calculator to start to explore and investigate these. So can I ask you now to play that game with me, pretend you are a child, and do this. And really do it. Talk to someone. It says discuss this with your partner. It says explain this, write down what you think, what is happening here. Make up a different example. Try and do that. Please try and do that now. I'll give you about 5 minutes. Go. If you don't have a partner, you'll need to get one. So perhaps you two can be together, and perhaps you two can be together. Either you move to here or you move to there. Somebody to talk to. Don't be a teacher, be a student. Okay? Do it now.
let me stop you there. I just wanted to give you the feel of this activity. If I was teaching students who are just learning about fractions and decimals, we would spend much longer doing that. But what is this for? In the teacher's notes, which come with this publication, I said here, the intention is for students to appreciate that fractions are single numbers, not pairs of numbers. Every fraction is just one number. It fits in one place on the number line. That's one important thing to realise. I would actually get students to use their calculator to put the fraction on the number line. Draw the number line on paper and put the fraction 3/5, 2/3. Is it in one place? No. The second thing I want students to learn here is that there are lots of different fractions that are the same number. We wouldn't necessarily call them equivalent fractions, but that's the idea. That 4/10 and 8/20 and 2/5 are different fractions, but they are the same number, but they are at the same place on the number line. I want students to know that. Those two things, many students learn fractions and they never learn them. They don't learn those things at the moment. So they are important things to know. And the second activity, number 2, is about students realising that you can change fractions from one form into another. In English we call it cancelling. Students often do it without thinking about what it is. They are just doing it without thinking. I want them to know what happens. And the last example is showing again that we can represent fractions in different ways. So these are examples of what I would be getting students to do with the calculator. They're not doing computation. I don't care about 2/5 added to 3/4. I don't even think it's worth teaching. But they are learning about what is a fraction and what does it mean, and what is a decimal and what does it mean, and how are they related. They are learning what I think are important things by using the calculator to investigate and to explore. So that's one example. You might think of better examples, but it has to fit on one page. I decided to put things on one page. And with students that were just learning this, we might also have a class discussion. I'd ask the students, how many different fractions can you find that have the same fraction as 3/10? And there will be lots of them. Some students will find crazy examples, 300 on 1,000, 3 million on 10 million. Many, many examples, but they will all be the same. So that's an idea which I hope you find interesting. So I've got only 20 minutes left for this session, and I had a few other things to do as well. So, well, let me before I start, let me ask a question. The teachers who are here, do you usually do things like that with calculators? Is that a common activity? Can you repeat that question for me, or someone in Thai? Is this a typical activity in Thailand?
อาจารย์ได้ถามว่าสำหรับคุณครูที่มานะคะอาจารย์ได้ถามว่าในเวลาในห้องเรียนเนี่ยอาจารย์ได้ใช้กิจกรรมลักษณะนี้โดยเครื่องคิดเลขกับครู
I'm just concerned that I'm not telling you things you already know. This is why a calculator is useful. to be able to. Okay, there's a couple of other little things I want to show you before we have a break for lunch. Yeah, okay. So, firstly, in your calculator, let's put in the square root of the square root 1, 2, 3. Notice there's a special symbol for squared. 3 squared is just quicker, and you don't have to go down again. 3 squared, add 4 squared. What do you expect for the answer? You expect 5. It's a triangle, right? 3, 4, 5. Very famous triangle.
Every student learning trigonometry and the Pythagoras theorem has this famous triangle. And of course the result is 5. If you had another famous triangle, like say 12 and 5, 12 squared, as you can edit to get another one and get 13. And students that are doing something like that might need to do it several times. If they are doing some elementary exercises in geometry, they have lots of these to do. So the calculator can automate some things. What does that mean? Well, enter this expression. Square root of not 3 and 5 and 12 and so on, but a. Use a variable. Alpha a squared. Add alpha b squared. Do not press equals. If you press equals, the result will just use the present values of a and b, but I don't want to do that. Instead of pressing equals, I want you now to press calc. C-A-L-C, calc. Now, it tells me the values of A, and I'm going to change that to be, say, let me think, 6. So type 6 and equals, and it tells me the value for B. So I'm going to type 8 and equals. So now I've got A is 6 and B is 8. Now press equals one more time. And the result is 10. Press calc again. And now you can use different. So A is 15. B is 8. And the result is 17. So we're doing a fresh, can you see what's happening? Doing a fresh calculation each time. Press calc again. A is 5, B is 6. The result is the square root of 61. So we can do lots of calculations of the same kind. If we are in geometry or measurement, and we're finding, say, the volume of a sphere. This is a different example. Volume of a sphere is 4/3 times pi. Pi is on the bottom. Shift and it's down here. And we don't have an R, but let's use X. There's an X over here. And it's cubed. So the volume of a sphere with radius x is that. Press calc. And it says, what's x? 5. Equals, equals. There is the volume. Press calc again. X is 7 this time. Equals. There is the result again. If you want a decimal result, of course, you can always get one. If you have something larger, more complicated, so for example, the volume of a cylinder is pi times x squared times the height. Let's make, say, alpha d, the height, d for height. Pi times the x squared times the height. Calc. What's x? 5. What's d? 4. There is the volume. So the calc button allows you to calculate things easily. If you have an expression like x squared add x add 5, say, some expression. Calc. What's x? 3. The result is 17. Calc. What's x? 12. The result is 161, and so on. So the students can use the calc command to do some calculations, which for some purposes is really, really helpful. Okay, that's what the calc button is. Factors. You saw me before find some factors. So let's put in a big number like 1, 2, 3, 4, 5, 6, 7, 8, 9 equals 123,456,789. What are the factors of this? There is a command here that says fact. Shift and fact. And it says it has a factor of 3 squared, but I'm not sure about this. We don't know. It might be a prime number, it might not. I got a bit ambitious. Let's put in a smaller. 1, 2, 3, 4, 5, 6. Factor. 2 to the 6th by 3 by 6, 4, 3. Now this is quite handy, as you saw me earlier use in this sort of way. 7 to the power 3 multiplied by 7 to the power 4 is a very large number. What are the factors? Shift and fact. 7 to the power 7. I'd like students to think about, what does that mean? Why is it like that? Why is the 3 and the 4 added together? Is that what's actually happening? What if instead of, and students can use their calculator as a what if machine. What if that was not 4, but that was, say, 2? I think it might be 7 to the power 5. And it is. That's a good feeling if you're a student. And what if it was not 7 to the 2, but say 7 to the 6? I think it will be 7 to the power 9. And it is. That's very reassuring. So there's quite a powerful command to find factors. Okay. We're still finding our way around the calculator here and thinking about some mathematics as we go. Sometimes young students are beginning to learn about equations. So let's think of a very unsophisticated example. I'm going to use x. So think about it. I have a number and I double it. 2 times x, and then I add 7, and the result is 19. So I want you to, this is a bit tricky, so I'll put the thing up back again. You need to tap alpha and the calc button. See the little red equal sign? Alpha and calc. So 2x add 7 is equal to 19. Now we would like students to think, okay, I have a number, I double it, I add 7, I get 19. So before I added the 7 we must have had 12, and before I doubled it we must have had 6. So I'd like them to think like that. But we can also put into the calculator, we can ask the calculator to solve. Don't press equals, not this one, solve. How do we do that? Shift and the calc button again is solve. Now the calculator is actually saying, at the moment x is 12, because last time I used it, it was 12, and I haven't changed it. But to find the solution when x is 12, for x, just tap equals. So when x is equal to 6, the left side is equal minus the right side is equal to 0. When x is 6, this is 19, and so is that. So the calculator can help students think about solving an equation. Let's make a slightly more complicated equation. I'm editing this. 2x subtract 2x add 7 is equal to 3 subtract 3x. That's a bit harder to think about. We couldn't think about it like I did before. But on the calculator, shift and solve. This is the starting value. We'll start with a value. Make a guess. 5 will do, anything. And tap equals. And the result this time is negative 0.8. When x is negative 0.8, the left side and the right side are the same. And if this equation was a bit different, we would get, of course, a different answer. Now x is 1.2. So that's solve. There are, of course, more sophisticated equations. We'll deal with those later today. The last thing I want to do before lunch, and we only have 5 minutes, you can see that so far we haven't done anything other than work in this same mode. Just want to explore the rest of the calculator a little bit. We will do this later today as well. If you tap the menu button now, I'll just tap menu, you can see, and Kimura-san referred to this earlier, we can see different things to do in the calculator. If you move around with the cursor, complex numbers, numbers to different bases, matrix, vectors, statistics, probability distributions, a spreadsheet, and a table. Many different things. Students who use the calculator a lot probably won't move around like this. They will just remember, for example, that the table is number 9. But, so I'm around here somewhere, I'm just going to tap number 9. And that's what happens. I'll do that again, as you will. just going to say menu and number 9. And now we're in the table part of the calculator. Young students find it very helpful to have a table of values. So let's think of an unsophisticated example. We'll just find x squared add 1. Just type it the same way we would normally write it. And we can have 2 variables, but I'm not going to have a second one. So just press equals. Ignore that one for now. A table of values starts somewhere, stops somewhere, and goes up with a step. On this calculator, it's only a small calculator, you can only have 30 values. So if we start at 1, tap 1 for start, end 30, and 1 for the end, that's okay. We'll have 30 rows in a table. And as soon as you press equals, there's the table. And we can see, you can move around and go over the top. You can see the values. But you might say, what if x was not 7 or 8, but 7.5? Just get rid of that. Watch this carefully. See where my cursor is at the moment? Move to the left in the x column and type another number. Not 7, but say 7.3. And there you can see there is 7.3 squared and 1. Or if we didn't want 7.3, 7, 38, 109.21. And notice in the table, the value over here is quite small in the table, but quite large down here. The table is not large enough to hold the number, but the number is on the bottom. This is quite small, this is quite large. But we can put any number in there. What if we wanted pi? That's okay. There's pi squared, add 1. What if we wanted negative 75.1? That's okay. It's a positive number. So a table is very useful, and we will use tables a lot later today. But I just wanted you to see the basic idea. And I'll finish with the observation. If you wanted to change the function, tap clear and put in a different function, like a linear function, say 2x add 4. If we put in too many values, so 1 to 30, if we went up in halves, a step of say 0.5, that will be 60 values in the table. And it's too many. The calculator will not allow 60 values. If we wanted to go up by halves, we maybe have to just go up to 15. That's okay. Notice with a linear function, it goes up steadily, the same amount each time. So there's things to learn about functions, as we'll see in the next session, using the table. Okay, it's lunchtime. So in this session, what we've been doing is getting started, learning to use the calculator, adjusting it a bit, seeing what it does, and thinking a little bit about the mathematics. And a little bit, a very little bit, we'll say more about that in the next session, about linear functions. So in the next session, we're going to do some slightly more sophisticated mathematics for slightly older students. Only slightly, not a lot older, still in school. So it's time for lunch. Thank you. Presume lunch is outside?
อาจารย์ครับ อันนี้เป็นเซสชั่นของช่วงเช้า อาจารย์ท่านใดมีคำถามไหมครับตอนเช้าก็จะเป็นช่วงของการสร้างความคุ้นเคยกับแคลคูลเลเตอร์นะครับอาจารย์ แล้วก็มีกิจกรรมให้อาจารย์ทำนะครับ แล้วอย่างตัวกิจกรรมที่อาจารย์เขาให้ทำเรื่องของ decimal กับ fraction นะครับเขาก็ชี้ประเด็นให้อาจารย์เห็นว่าจริงๆแล้วเนี่ยกิจกรรมคือไม่ใช่ว่าเราแค่ทำตามเฉยแต่เราคิดว่ากิจกรรมเนี่ยจะให้อะไรคอนเซ็ปต์อะไรกับเด็กนี่คือสิ่งที่เราเอาไปใช้กับเด็กเนี่ยกิจกรรมตรงนี้จะให้อะไรกับเด็กนะครับที่เขาเน้นย้ำว่าเขาจะพยายามให้เด็กเนี่ยเข้าใจว่า fraction ในหลายๆตัวเนี่ยแทนจำนวนหนึ่งอะไรอย่างเงี้ยครับอะไรที่อยู่เบื้องหลังของกิจกรรมเขาพยายามจะให้อาจารย์ตรงนี้นะครับท่านใดมีคำถามไหมครับถ้าไม่มีคำถามก็เวลาพักรับประทานอาหารกลางวันนะครับอาจารย์อาหารเป็นบุฟเฟ่ต์อยู่ทางด้านนอกนะครับอาจารย์ตัดแล้วก็เข้ามาทานที่โต๊ะได้นะครับแต่ก็ขอความกรุณาอย่านำภาชนะไปที่อื่นนะครับก็จะมีที่จัดเก็บให้อยู่ด้านนอกครับโอเคครับ That's all. Alright, time's for lunch.